Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find the volume of solids as a result of rotating the bounded region about an axis. Okay, so in this example, we're going to be solving this problem incorrectly first, making a mistake or multiple mistakes, and then we'll go over what the correct procedure is. Okay. So the instructions are for us to set up the expression to find the volume of the solid resulting when the region R, the region bounded by these two curves in the first quadrant, is rotated about x equals -1. Okay, so in this problem, we're rotating our axis around x equals -1. So let's go ahead and sketch our axis of rotation. That's our axis of rotation right there. Now, in order for us to set up our problem, we're going to write down the formula for finding the volume resulting by revolving this region between these two curves around the x-axis. Now the formula for volume of a solid of revolution is pi times the integral from a to b of r outer minus r inner square. Okay, so let's go ahead and find the outer radius first. Our outer. Let's name our two functions. Let's call this g of x, and let's call the other function f of x. Okay. All right. So our outer is going to be. Let's draw our orient our radius. So this is the orientation of our radius. Since we're rotating about x equals -1. That is a vertical line, x equals -1. Now the outer radius is a measure from this end all the way to the axis of rotation. Okay, that is our outer radius. So this is our outer. So what is our outer? Our outer radius is going to be g of x minus the line, so it's going to be g of x minus the axis of rotation. So if we apply this problem to this formula, we are going to have g of x is the square root of x minus a, which is -1. So it's going to be the square root of x plus 1. The inner radius, our inner, is going to be the measure of the distance from this point all the way to your axis of rotation. Okay, that is our inner radius, our inner. So our inner is going to be f of x minus our axis of rotation a. So that's going to be the cube root of x minus -1, and we have the cube root of x plus 1. All right, so now that we have our outer and inner radius, let's go ahead and write down the volume. So our volume V is going to be pi times the integral from a to b. The point of intersection here is 0, 0. And then the point of intersection here is 1, 1. So our slices are going from the bottom to the top. So from 0 to 1, so integral from 0 to 1 of our outer, which is, let's see, our outer is root x minus 1, root x minus, plus 1, minus our inner, which is the cube root of x plus 1, quantity square dx. Okay? So there goes the final incorrect answer. So the question now is, can you find the fallacy or fallacies in this problem solving process? Can you identify where I made the mistakes? So there are two main areas that I made a mistake here. The first one has to do with my formula. the correct formula is r outer square minus r inner square. So this is the first mistake that I made. And then wrong formula. And then the next mistake that um, was made is in the functions. If we're orienting our radius in a horizontal direction, this functions must be in as a function of y. So this should be a function of y, and this should be a function of y also. So those two are wrong functions. We're using the wrong functions. So that's another mistake that we made in this problem. Okay? All right, so let's go ahead and do it correctly. Okay, let's take a look at the correct way of solving the problem. All right, so one thing that you want to do to help um, you solve this problem correctly. So one thing to make sure we have to do when solving the problem correctly is we want to always use the formula in terms of the variables. Okay? So first thing we're going to do is orient the radius. So that's our region right there. Since we're rotating around a vertical line, x equals -1, our orientation is going to be perpendicular to that axis. So our radius will be oriented in this fashion right here. And another thing to help you get the answer correct is by making your slice a rectangle. Now, what is the thickness of this rectangular slice? Since we're measuring it in the up-down direction, it's going to be dy, an infinitely small y length, okay? So since we're perpendicular to the x, that's one way to tell you that all our variables should be in the axis perpendicular to that, which is y. Or since we have dy here, all our variables should be y, okay? So let's write down the formula in a way that prevents us from making mistakes. So our volume V is going to be pi times the integral from, now this slice is going to be going from the bottom to the top. We're going to be looking at the y coordinates. So from y bottom, from y bottom all the way to the y top, times the outer radius, r outer, and then we want to specify what function this is. It's a function of y, r outer y square minus r inner of y also square, and then this whole thing dy. Now take a look at this formula closely, and then if you look at the other formula we used here, notice I did not specify the variables. That's why it's easy to get confused with your orientation. Secondly, I squared the difference of the radii. That is wrong. You have to square the radii independently. Okay, pi r outer square is the area of the outer disk. Pi r inner square is the area of the inner disk. When you subtract them, you have the area of the washer. Okay, so let's go ahead and figure out what the outer radius is. R outer as a function of y. So the outer radius is the measure from this point right here all the way to your axis of rotation. Okay, so that's your outer radius, r outer. And then your inner radius is going to be the measure from this point right here all the way to your axis of rotation. Okay, that will be your inner radius, r inner. Okay, so let's do our outer first. So our outer, now since it's a function of y, this right here is a function of x. This is f of x. So how do we make it a function of y? What we'll simply do is take the inverse, find the inverse of this function. So if y is equal to square root of x, we'll simply square both sides to solve for x, and then we'll get x equals y squared. Now this is a function of y. Okay, so this is f of x, but we need f of y, so f of y is y squared. Now let's take a look at the other function. This function is a function of x. We need a function of y for the inner, so we have to do the inverse again. So y equals the third root of x. So to get y isolated, we'll raise both sides to the third power. Okay? So raise both sides to the third power, and then you have x equals y to the third. Now this is a function of y. That is what we want. F of y equals y to the third. Okay, so our outer radius is going to be f of y, which is y squared, minus the axis of rotation. Okay, let's write this down as, correct that real quick. F of y minus a, and then if we substitute it, we're going to have f of y is y squared minus the axis of rotation, which is -1. F of y equals -1. Simplify that, we are going to have y squared plus 1 as your outer radius. And then your inner radius, our inner, as a function of y, is going to be, well, let's call this g of y, okay? Call this g of y right here. And then we'll call the other one f of y. Okay, so our inner is going to be f of y minus your axis of rotation. That's the formula there. And then if we do the correct calculations, we're going to substitute y to the third here. So we have y to the third minus your axis of rotation, -1. And that reduces into y to the third plus 1. Okay? So now we have our outer and inner radius. We're now going to plug them into the correct formula. So our volume V is going to be the in pi, don't forget the pi, times the integral. This slice goes from the lower x, which is 0. This point right here is 0, 0. So this is y bottom, all the way to y top. This point right here is 1, 1. So this coordinate, the y coordinate, is what we're looking at. Y bottom to y top. Let's write the top properly. Y bottom to y top is going to be from 0 to 1. Okay, so it's going to be, you're going to be going from 0 to 1 of the outer function, the outer radius, which is y squared plus 1, minus, no, so we have to square that, square, minus the inner radius, y to the third plus 1, square dy. Okay, so this is the correct setup to find the volume when this region R is rotated about x equals -1. So let's box our correct answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you have any questions about this tutorial or any questions about finding volumes of revolution, feel free to include your questions in the comment section below, and we'll be glad to answer it as soon as possible. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com under the AP Calculus section. Thanks again for watching.